After studying this module, you shall be able to understand the concept of multiple regression. Learn the method of making predictions, as in how does the outcome change if there are many predictors. Analyze the applications of multiple regression. Identify the situations in which one can apply multiple regression. Understand the application of SPSS 20 for multiple regression analysis. The fate of a movie is counted in terms of the money it earns, through the number of people it attracts. A movie becomes a hit and the masses come when all the ingredients of the film fall in place. At the same time, it is quite possible that one component, like the music, may have had an important role in drawing the audience to the theatres, even if the story was not that interesting. At the same time, a good story can make a small budget film without big stars also a huge success. Thus, it would be interesting to see whether and how measures like star cast, story, music, dialogues and publicity relate to the success of the film. What I want to say by this example is that out of the number of available variables influencing the fate of a movie, which one have contributed significantly would be interesting to know. This would perhaps be useful for other film makers too, as to how to prepare a perfect recipe for a successful film in future. That is to start the lesson on lighter note. But in psychological research too, one may come across variables that are detrimental to a particular variable. It is interesting for the researcher to know which factors contribute significantly in determining the value of another variable. This can be achieved by applying the statistical method of multiple regression. The readers already have a knowledge related to simple regression analysis, its applications and assumptions. The current module would explore the concept of regression further and explain how it can be extended to multivariate situations as multiple regression. The multiple regression is a term first used by Pearson in 1908, and his aim was to understand more about the relationships between many independent or predictor variables like the components of the film discussed in the example above, and a dependent or a criterion variable, that is the audience response to the released film. The social and natural sciences also use multiple regression procedures widely, as they allow the researcher to ask what is the best predictor of such and such variable. For instance, educational researcher would want to know what predicts success in high school. A clinical psychologist would want to know what predicts a good quality of life for an individual. And we have so many variables that may contribute, but to identify which one are significant contributors can be known through multiple regression. What is multiple regression? Multiple regression is a statistical tool that allows one to examine how multiple independent variables relate to a dependent variable. Once this identification is made, information from all the independent variables can be taken and used to make more powerful and accurate predictions about the way things are and why they are like that. In order to calculate the effects of two or more independent variables on a dependent variable, multiple regression method is used. It enables one to predict and weigh the relationship between two or more explanatory or independent variables and an explained dependent variable. For instance, Level of achievement in an examination may not just be affected by the study time, quality of teaching, amount of practice only, but also the level of intelligence possessed by the students. Now, if one wishes to see how many marks a student would obtain if he or she studies for 30 hours per week and has an intelligence score of 110, then it can be carried out only with multiple regression method. Thus, multiple regression help the researcher to see the predicted effects of a particular independent variable on a dependent variable when other independent variables are also present. It takes in a range of variables and enables one to calculate the relative weighing of independent variables on a dependent variable. But one must be cautious in the sense that variables may interact with each other and they may be intercorrelated too. We shall study this as we go through the text. The model for multiple regression. A reading of the modules on regression and simple regression analysis would make the readers realize the importance of the line of best fit in regression and prediction. The relationship between variables can be best described by fitting a straight line running through the data points with minimal deviances as functioning on the least square criterion, thus leaving the scope for minimal residuals. The straight line becomes our model, which is used to predict the values of y, that is the criterion variable, from the values of x, that is the predictor variables. In multiple regression, we have a number of x and we shall see them to be classified as x1, x2 and x3 also. This straight line assesses the fit of the model by looking at the deviations between the model, which is largely the mean model and the actual data collected. The mean model is the simplest model available because on an average it will be a fairly good guess of an outcome. These deviations are the vertical distances between what the model predicted and each point that was actually observed. The differences mentioned here are called residuals. The data points fall both above, which shows that the model underestimates their value, and below the model, which shows that the model overestimates their value, resulting in both positive and negative differences. Since these differences cancel each other on summing them up, the differences are squared to overcome this problem. The squared differences give an assessment of how well a line fits the data. Multiple regression becomes an extension of the linear regression model studied earlier, just that the situation has several predictors now. The equation basic remains same. We have an outcome, then we have a model which has its share of errors. But here, for every extra predictor included, a coefficient is added. Hence, each predictor variable has its own coefficient and the outcome variable is predicted from a combination of all the variables multiplied by their respective coefficients and a residual term. So, the simple linear regression equation that we just studied hence has a new way to express itself. The multiple regression analysis turns out to be the predicted y is equal to b0 plus b1 x1 plus b2 x2 till we have exhausted all the n number of predictor variables, and of course the error term remains same. So, the y is the outcome variable, b1 is the coefficient of the first predictor x1, b2 is the coefficient of the second predictor x2, bn is the coefficient of the nth predictor xn, and e is the difference between the predicted and the observed value of y for the ith participant. X is the scores of the independent variable. Hence, we are trying to find the linear combination of predictors that correlate maximally with the outcome variable. The readers would note that the regression coefficient, that is the beta coefficients, signify the each independent variable's unique contribution to the prediction of the dependent variable. The regression equation thus obtained provides the best prediction of a dependent variable y given the number of x variables. However, one would agree that it is not easy to predict the variable with 100% accuracy, as deviations from the line of best fit always are there to disturb a perfect relationship among the correlated variables. Therefore, there are apparent variations in the observed and the predicted scores, which are shown in the regression line as the residuals. The residual variations are computed using a statistic called R square, that is the coefficient of determination. The variability of the residuals around the regression line should be minimal to expect the predictions to be free from errors. This can be explained further. If the variables x and y do not share any relationship, the ratio of the residual variability to the variance would be 1. In this case, R square would be 0. Similarly, if the correlation between the two variables x and y is 1, that is a perfect relationship, then R square would be 0. In research data, this value is between the extremes, that is 0 to 1. The coefficient of determination, represented as R square, indicates how well the model fits the data. An R square of 0.4 would imply that 40% of original variability has been explained by the model, while 60% residual is unexplained. Assumption in multiple regression. Multiple regression model assumes linearity in relationship. The relationship between the variables should be linear. This simply means that the relationship between the two variables being considered for simple regression can be described using a straight line. This assumption can be easily checked by drawing a scatter plot. It is imperative that the data is checked for outliers, as they have a detrimental impact on the quality of results. If the outliers are present, then suitable corrective measures should be employed. Normality. Whenever a researcher wishes to use a regression line for the purpose of prediction, it should be made sure that the distributions for the variables x and y are normal. If the distributions deviate from normality, then the skewness should not be high. The assumption of normality in a bivariate distribution can be checked by using the method of histograms. Multinormality. When complex regression analysis needs to be taken up, the assumption of normality proves insufficient and multinormality needs to be checked. All the variables chosen to be part of the regression model need to be multinormal. A set of k variables is said to have a multivariate normal distribution if, given any set of values of k minus 1 of them, the remaining variables are normally distributed. Multinormality is an assumption which is imperative to multivariate techniques and is therefore a must in multiple regression analysis. Multinormality can be tested using a QQ plot, and relevant transformation like the log linear transformations can be used for correction. The other assumption is of homoscedasticity. The homoscedasticity refers to the uniform spread or scatter of scores throughout a distribution. It is assumed that the estimated or the predicted values are scattered uniformly around the observed values for all the observed scores of the distribution. This enables the researcher to use a uniform or the same measure of spread, that is the standard error of the estimated variable. To put it in other words, one may assume that the range of permissible fluctuations in the predicted values of the variable are same for all the observed values. The assumption of multicollinearity. The multicollinearity occurs when the variables share a high degree of covariance among themselves. For accurate regression analysis, multicollinearity should be avoided. The multicollinearity in the data can be assessed using certain statistical criteria like the correlational matrix, tolerance level which is represented as T, and T is equal to 1 minus R square. Whenever T is less than 0.01, it indicates multicollinearity. The variance inflation factor, that is the VIF, is 1 upon T, and VIF, if it is greater than 100, then it confirms multicollinearity. And the condition index is also another measure to check multicollinearity. Of course, multicollinearity can also be corrected using the relevant methods, and we may study them in detail in the module on Introduction to Multivariate Analytical Techniques. Another assumption is of autocorrelation. The residuals should be independent of each other. The practical application of regression analysis. The multiple regression method can be employed to the areas of demand management and data analysis in the field of business. Social, psychological, or any research for the fields like agriculture can also use the multiple regression analysis to predict the yield of the crop, for instance, in agricultural sciences. The focus of analysis for multiple regression is in quantitative psychological research is to analyze the extent to which two or more independent variables relate to a dependent variable. The variables involved are, there may be two or more than two independent variables which are continuously scaled. The dependent variables are also continuously scaled, that is either interval or in ratio scales of measurement. Relationship of the participant score across the groups being compared is to be suitable for the multiple regression analysis is that the participants should have scored on all the variables, or in other words, the scores are dependent upon each other. The assumptions underlying multiple regression analysis have also been discussed in the text previously, and some of them are for normality, homoscedasticity, linearity, independence of errors, multicollinearity, etc. Using SPSS for regression analysis. The Pearson's product moment correlation is a popular statistical method to assess the basic statistics in regression analysis. There are three types of regression analysis: standard or simultaneous regression analysis, sequential or hierarchical regression analysis, statistical or stepwise regression analysis. The standard or simple regression analysis is also referred to as simultaneous regression analysis. All predictor variables are entered in the regression equation at once, and each predictor variable is evaluated in terms of what it adds uniquely to the prediction of the criterion variable. Simple regression analysis is used in exploratory and hypothesis building regression model, although it is much less used in quantitative research. The multiple regression analysis SPSS commands. The commands are as follows: open SPSS data file called MRA data and click on Analyze, go to Regression and to Linear. Click over DSI under Dependent. Under Independent or Independents, click over SPScience and then click on the next button to the upper right. The SPScience disappears and the program stores the first predictor variable for you. Click over the SPI practitioner and click on the next button. You have set the model that you want to test. Click on the statistics button, check on estimates, confidence intervals and type in 95 besides level percentage. Check on model fit, R-squared change, descriptives, part and partial correlations and collinearity diagnostics, and click on continue. Click on the plots button and click over Z residual to the Y box and Z predictor to the X. Under standardized residual plots, click on histograms and normal probability plot and click continue. Click on the save button. Under distances, click Mahalanobis and click continue and click OK. Summary: multiple regression is a term used first by Pearson in 1908. His aim was to understand more about the relationships between many independent or predictor variables. Multiple regression is a statistical tool that allows one to examine how multiple independent variables relate to a dependent variable. Multiple regression becomes an extension of the linear regression model studied earlier, just that the situation has several predictors now. Each predictor variable has its own coefficient and the outcome variable is predicted from a combination of all the variables multiplied by their respective coefficients and a residual term. Hence, the new equation for multiple regression analysis is B0 plus B1 x1 plus B2 x2 till all the variables, that is the predictors, are exhausted plus the error term. The multiple regression method can be employed in the areas of demand management and social and psychological research. Along with this, the text also helps the reader in using SPSS 20 for analyzing the data for multiple regression analysis.